Hey everyone, welcome back to the Systems Podcast, the show where we break down the systems behind modern software, startups, AI, infrastructure, and engineering at scale. Whether you're a software engineer, founder, student, or just someone obsessed with how complex systems work, you're in the right place. Let's get into it. So right now, the world's most powerful tech companies are on track to spend uh, $400 billion this year on a technology where the underlying products are actually rapidly becoming indistinguishable from one another.
Yeah, it's a staggering amount of capital.
hmm
And that commoditization is exactly why half the industry is kind of in a state of panic right now.
Right, and that panic is what we're unpacking today. We're doing a deep dive into tech analyst Benedict Evans' massive report, AI Eats the World. And our mission for you today is to look at the underlying data and answer this burning question. Is generative AI just an overhyped bubble, or is it a fundamental platform shift? We want to dig into the mechanics of who actually wins, who loses, and how this whole infrastructure build-out is going to rewire your daily work.
Exactly. And to figure out if this is a bubble or a real structural shift, we basically have to look at the anatomy of historical technology cycles. Because every 10 to 15 years, the industry goes through this tectonic shift that completely rewrites the rules of distribution.
Like going from mainframes to PCs, right?
Right, mainframes to PCs, and then, networking those PCs via the web, and then unchaining the web through mobile. And during each of those windows, the incumbent titans seem like these unmovable monoliths. But their dominance is actually incredibly fragile.
Because their expertise is so tied to the previous paradigm.
Exactly. I mean, look at Microsoft. Between 1980 and 2015, they held a near monopoly on the PC operating system market. They literally dictated the terms of software development globally. But when the platform shift to smartphones happened, they tried to force a desktop paradigm onto a modal form factor.
Yeah, the Windows Phone was just, it was a fundamental mismatch.
It was, and because of that, they lost the market completely to Apple and Android.
And that historical trauma is really the invisible hand guiding corporate strategy today. I mean, you
Yeah.
look at Mark Zuckerberg pouring tens of billions into hardware research, shipping those Ray-Ban smart glasses.
Oh, yeah. That's not just some experimental side project for Meta.
No, not at all. It's driven entirely by a desire to escape Apple's mobile ecosystem. He lived through the last shift as basically a tenant on Apple's property. He suffered through the App Store fees, the privacy changes that completely crippled his ad targeting.
Right, the app tracking transparency update just gutted them for a while.
Exactly. And he is just refusing to be a tenant in the next era. And honestly, it also perfectly explains Microsoft's massive, multi-billion-dollar early bet on OpenAI.
Yeah, Satya Nadella looked at the graveyard of the mobile shift, saw Microsoft's own tombstone sitting there, and decided, we would rather overpay for the future than be left managing the legacy systems of the past.
Because the graveyard of past shifts is huge. You think about companies like AOL and Yahoo during the transition to the modern internet.
Or Nokia and BlackBerry during the shift to capacitive touch smartphones. I mean, they were the defining companies of their era.
Right, but previous winners are never guaranteed a seat at the table in the next revolution. Platform shifts are basically a giant game of musical chairs for trillion-dollar companies.
That's a great way to put it. The music is playing, the hyperscalers are dancing around, but when it stops, someone is going to be left without a seat. Capital and engineering talent are just ruthless. They abruptly switch over to the new primitive, which is generative AI right now.
But comparing the AI shift to, say, the PC or mobile shift kind of breaks down when you look at the predictability aspect, doesn't it?
It does, yeah, because with hardware-based shifts, we had Moore's Law, we had physical manufacturing benchmarks, we knew a phone screen could only get so much sharper, or a mobile processor would reliably get 20% faster next year.
Right, you can map it out on a spreadsheet. But with large language models, we are entirely in no man's land.
Exactly. The absence of physical constraints makes forecasting nearly impossible right now. We don't know the ceiling of transformer models. We don't know if the current scaling laws where pouring in more compute and more data reliably yields a smarter model is going to hold up.
Like, are we going to hit an algorithmic plateau next month? Or does it just keep going straight up infinitely until it solves, autonomous reasoning?
Nobody knows.
Yeah.
And because the underlying science is unpredictable and the stakes of missing the shift are literally existential, the capital deployment we're seeing is entirely unprecedented.
Which explains the sheer panic driving the capital expenditure. I mean, going back to that $400 billion figure, these companies are so terrified of losing their chair when the music stops that they're inflating this massive inside tech bubble.
Yeah, and Google CEO Sundar Pichai captured the psychology of this moment perfectly. On a recent earnings call, he flat out admitted the risk of underinvesting is significantly greater than the risk of overinvesting.
Wow. Yeah, because for a company like Google, underinvesting is fatal. Their entire profit engine is built on being the starting point of the internet.
Right. If user behavior shifts away from typing keywords into a search bar and moves toward conversational AI interfaces that synthesize answers directly, Google's ad network loses its toll booth.
And that dynamic, that deep fear of structural obsolescence, is driving this projected $400 billion in capex by Microsoft, AWS, Alphabet, and Meta in 2025 alone.
And when you look for the physical manifestation of that money, it is actively reshaping the industrial landscape. In the US right now, data center construction is literally overtaking office space construction.
That's wild, but a modern AI data center isn't just like a warehouse for standard servers, right?
Oh, not at all. It requires massive industrial cooling, reinforced concrete just to handle the physical weight of these GPU racks, and dedicated substations just to handle the power draw.
And the corporate behavior around securing that infrastructure borders on desperation. Look at Oracle. They're spending over 100% of their revenues on cloud capex.
Taking on massive corporate debt to fund it too.
Right. Because they lost the initial public cloud war to AWS and Azure, and they are leveraging their entire balance sheet to make sure they aren't relegated to just legacy database maintenance in the AI era.
Yeah, and then you look at OpenAI's aspirational infrastructure goals, and the numbers just stop making sense in traditional economic terms. They are modeling out the need for 30 gigawatts of data center capacity.
30 gigawatts, like to put that in perspective for you listening, that infrastructure would cost roughly $1.4 trillion to build.
Yeah, and 30 gigawatts is equivalent to about 2/3 of the total global energy base used in an entire year.
So you would effectively need to spin up multiple nuclear reactors just to keep the models thinking.
Exactly. And the hyperscalers are funding this arms race through the sheer scale of their existing free cash flow. Alphabet and Meta print billions from their core advertising businesses, and instead of returning a modest dividend to shareholders, they are weaponizing that profit into server farms.
But the flow of that capital reveals a highly complex, interconnected web of dependencies. If we map out that web, it looks like a massive vendor financing loop.
Yeah, a circular economy.
Right. NVIDIA invests hundreds of millions into a company like OpenAI. Then OpenAI takes that funding and immediately uses it to buy NVIDIA's H100 chips. Meanwhile, the hyperscalers who generate NVIDIA's revenue in the first place are also paying massive premiums to run OpenAI's models on their cloud.
It feels less like a robust, diversified market and more like a high-stakes poker game where everyone is going all in on every hand but secretly passing chips to each other under the table to ensure the game doesn't end.
Is it a rational hedging of bets, or is it just a house of cards?
Well, the systemic risk is concentrated entirely in demand. NVIDIA uses its massive free cash flow to buy demand and create momentum. OpenAI uses its high valuation to secure hard computing assets. But the structural vulnerability is that if enterprise demand for AI wrappers falters, or if end users decide they don't actually need to query an LLM 50 times a day,
then the hyperscalers reduce their capex. And if capex drops, NVIDIA's revenue slows, the valuations contract, and that whole circular economy just stutters.
Exactly. But the most fascinating paradox of this $400 billion spend is the product itself. All this money and power is pouring into foundational models that are fundamentally converging.
Because everyone is building on the same transformer architecture.
Right, and they're all scraping the same public internet data, Reddit, Wikipedia, Common Crawl. So the models are hitting a data wall, and the output is becoming indistinguishable.
Which creates what the report describes as the potato seller problem. I love this analogy. If two vendors in a market are selling identical potatoes, those potatoes are commodities. The chemical composition is the same, the utility is the same.
So the vendors can no longer compete on the quality of the potato itself. They are forced to compete on price, on the trust they build with the buyer, and on the storytelling around the transaction.
And AI models are those identical potatoes right now. The open source models released in the last few months are matching the performance of the closed proprietary models from a year ago.
Yeah, the technical delta between a query run on OpenAI's GPT-4, Anthropic's Claude, or Google's Gemini is entirely negligible for the average consumer. They all just rotate the crown of best model in the world every few weeks based on fractional percentage points in some benchmark test.
So when the underlying technology commoditizes like that, the only defensible moat is distribution. The entity that reaches the customer first and builds a daily habit is the one that captures the value.
Look at the current usage data. ChatGPT has successfully captured over 20% of the U.S. population as weekly active users. Meanwhile, Claude, which engineers often argue is technically superior for certain coding tasks.
It's sitting at sub 3%.
Exactly. In a commodity market, technical superiority without distribution is meaningless.
So if you're an engineer or a founder listening to this and you're building an AI wrapper, you have to ask yourself, are you just setting up a potato stand next to Walmart? Like, does the tech even matter anymore, or is AI just a pure go-to-market and distribution war now?
If your only competitive advantage is calling an API to an LLM, you have zero competitive advantage. The real value is embedding the model so deeply into an existing workflow, like an enterprise CRM or a legal drafting tool, that the user doesn't even realize they're interacting with AI.
And that reality is dictating the two dominant opposing strategies we're seeing right now. Y Combinator startups are pursuing this aggressive unbundling. They look at a sprawling workflow and carve out a highly specific micro use case.
Like optimizing an Excel macro or drafting a specific type of cold email, and they build a hyper-focused tool around it.
Right. But OpenAI, conversely, is attempting to build the entire bundled stack. They're trying to recreate the network lock-in that Microsoft achieved with Windows.
Yeah, they aren't just selling an API. They're doing deep OS-level integration deals with Apple. They're building their own search browser to bypass Google. They're launching Sora to dominate social video, and they're investing heavily in robotics.
Because they want to ensure that if your entire digital life is built in their ecosystem, the switching cost of moving to a competitor's identical potato is just too high.
But the friction in OpenAI's bundling strategy brings us to the actual real-world deployment of this technology. The engagement numbers present a massive paradox that really challenges this narrative of an immediate, society-altering revolution.
Yeah, the gap between the hype and the daily utility is pretty stark.
It is. ChatGPT boasts roughly 800 million weekly users, which is staggering scale. But only 5% of those users are actually paying for a subscription. And daily active use remains surprisingly low, hovering under 10%.
Right, if only 5% are willing to pay for it, and daily use is sub 10%, that tells me the broader public currently views LLMs as a highly capable party trick, or at least just a sporadic tool, not a mission-critical operating system.
Exactly. They're using it to brainstorm a resume cover letter once a month or ask for a recipe rather than integrating it into their daily operations.
So how is it actually generating revenue outside of the tech bubble?
Well, the behavioral data shows that the primary validated value proposition is what Evans categorizes as the infinite intern model.
The infinite intern. I think this is the most crucial concept for understanding where we are right now.
Yeah, because a human intern possesses boundless energy. They can work around the clock, process massive data sets, and generate 1,000 ideas without fatigue. But fundamentally, an intern also operates with a 2 to 5% error rate.
They lack seasoned judgment. They require senior supervision and constant course correction.
Exactly. So when you accept that AI is an infinite intern rather than some omniscient oracle, you start to see why it's generating massive revenue in very specific sectors.
Like software development, tools like Cursor are enabling AI pair programming at scale. The AI operates as the intern, writing the boilerplate code and structuring the syntax, while the human engineer acts as the senior reviewer.
Right, checking for logic flaws and architecture coherence.
Yeah.
And in marketing, it's the same thing. Google is reporting that advertisers utilizing their AI Max tool are seeing 14% more conversions. Meta is seeing identical boosts across their ad networks.
And the success in marketing ties back to the psychology of the consumer, which Evans illustrates with that Nirma washing powder analogy.
Yeah, so decades ago, television commercials used incredibly simple, repetitive, low-production jingles. They were not high art, but they were ruthlessly effective. And they worked because consumer media consumption is a low-context environment.
When you are scrolling through a feed at night, you're not engaging in deep analytical thought. You're operating on low context. People complain about AI slop online, but a highly personalized AI-generated ad works perfectly in that environment.
Because if the algorithm detects intent for a specific type of running shoe and an AI instantly generates an ad featuring that shoe, the user doesn't care if a shadow in the background is rendered incorrectly or if an artifact is slightly blurry.
Right, the visual served its immediate purpose of matching intent with product.
Exactly. The tolerance for error is the defining metric for where AI succeeds and fails today. A consumer scrolling Instagram is highly forgiving of a 3% error rate in a generated image.
But an enterprise customer is absolutely unforgiving. Like an intern with a 5% error rate is fine when brainstorming a marketing campaign, but is it acceptable when that AI customer support agent hallucinates a non-existent refund policy during a live chat?
Or if an AI copilot introduces a zero-day vulnerability into foundational banking infrastructure, you can't have that.
Exactly. The successful deployments are entirely clustered in domains where the cost of a hallucination is near zero, and the economic upside of infinite scale is massive.
And that limitation, the cost of failure, is exactly why the deployment of this technology is going to fracture the labor market in very weird structural ways.
We established earlier that these platform shifts resemble musical chairs, and we really have to apply that analogy directly to the workforce. What does this mean for human jobs?
Well, historical bubbles prove that even when the financial exuberance pops, the underlying behavioral changes remain permanent. Following the dot-com crash, titans like Netscape, Sun Microsystems, and Pets.com were just wiped out. But the internet had already rewired human interaction.
Yeah, that stat in the report is crazy. In 1995, the percentage of heterosexual couples in the US who met online was mathematically zero, but by 2020 it had scaled to nearly 60%.
The capital dried up, but the societal workflow was permanently altered, and generative AI will execute the same permanent shift on the labor market.
And Evans highlights this brutal historical precedent with elevator attendants. In the 1950s, operating an elevator was a thriving middle-class profession employing roughly 100,000 people in the U.S.
Then the electronic push button was standardized.
Right.
And automation didn't just make the elevator attendant's job faster, it completely eliminated the necessity of the role.
The employment numbers plummeted straight back to near zero. Automation definitively removes jobs by removing the friction that creates those specific categories of work.
And as models become more capable, the structural risk isn't that an AI will suddenly replace a senior staff engineer or a chief marketing officer. The risk is the evaporation of the intermediate layers of white-collar work.
Right, the work that relies on synthesizing information, drafting initial reports, or writing basic functional code.
The exact tasks perfectly suited for an infinite intern.
And I want to leave you with this final, provocative thought to mull over. If you manage a team right now, this creates a massive structural problem that extends far beyond quarterly efficiency gains. If your company deploys AI to handle all the basic coding, all the initial marketing copy, and all the entry-level 3D modeling, you are effectively removing the chairs for junior employees. But the junior to senior pipeline is fundamentally an apprenticeship model. If the AI is doing all the foundational work, how does a junior employee ever get the necessary reps, the late-night debugging sessions, and the lived experience to eventually become that senior expert who supervises the AI? You might be saving money on intern salaries today, but you are potentially collapsing the pipeline of future experts your company will need a decade from now. That is the true cost of the infinite intern, and it is something every technical leader needs to be solving for right now. That wraps up today's episode of the Systems Podcast. If you enjoyed this episode, make sure to follow the podcast, leave a rating, and share it with another engineer or tech enthusiast. And remember, great products are built on great systems. We'll see you in the next one.